It was a red letter day for science and astronomy this 12th of July. It was a day when the first pictures from the James Webb Space Telescope were released to the world. You may have already seen those gorgeous pictures, and many might have already put them as your desktop or mobile wallpapers. In this video, I'm going to break down everything you need to know about the James Webb Telescope, from its origins, specs, how it works, and of course explain the first images and what it could teach us about the universe. At the time of making this video, there are more pictures that have just been released, so watch till the end for those stunning visuals. Talks about building a next generation telescope to better the Hubble telescope began in the 1980s and picked up steam in the mid-90s. Obviously, it was NASA who spearheaded the mission, and they joined hands with the Canadian and European space agencies and instructed the American aerospace and defense technology manufacturer Northrop Grumman to develop a highly sensitive and largest of its kind telescope which would sit in space and click pictures of our universe. It was finally commissioned and assembled in 2016 and took off from French Guiana on Christmas Day of 2021. The cost of the build? A cool $10 billion. The James Webb Space Telescope, or JWST, has 4 key goals. 1. To search for light from the first stars and galaxies that formed in the universe after the Big Bang. To study galaxy formation and their evolution. Number 3. To understand star formation and planet formation. And most importantly, number 4. To study planetary systems and spot the origins of life. The JWST is essentially an observatory which is deployed in a solar orbit near the Sun-Earth L2 Lagrange point, about 1.5 million kilometers from Earth, where its 5-layer sunshield, each layer as thin as a human hair, protects it from warming by the Sun, Earth and the Moon. The sunshield itself is the size of a tennis court. All of this were folded and sent up in a rocket, and once it reached the L2 Lagrange point, it was unfolded and placed in position so that it can unfold the secrets of this universe. It examines space through infrared light. JWST's primary mirror consists of 18 hexagonal mirror segments made of gold-plated beryllium, which is combined to create a 6.5 meter diameter or 21 feet mirror. Compare this with Hubble's 2.4 meter mirror. This gives JWST a light collecting area of about 25 square meters, about 6 times that of Hubble. It can detect objects up to 100 times fainter than Hubble can. Unlike Hubble, which observes in the near ultraviolet, visible and near infrared areas of the electromagnetic spectrum, JWST observes in a lower frequency range, from longer wavelength red visible light through to mid-infrared range. Just see the difference in clarity between the pictures taken by Hubble telescope and James Webb telescope, and you will see why this is such an important leap for astronomy and science. So what is the specialty of seeing things in infrared? Well, that is because this telescope is designed to see as far as we can back in time. Now, as light travels through the universe, light gets stretched due to the expansion of the universe. Light waves which are longer in wavelengths appear redder. Now, the light from the most distant galaxies, they are so far away that their light has been stretched so much that it is out of our visible light spectrum and is in the infrared portion of the electromagnetic spectrum. And James Webb can see that. So using this technology, we are literally going back in time around 13.6 billion years back. Yes, this is literally a time machine that we have placed up there. Just imagine being able to go back in time and take a picture of a dinosaur. This is similar to that. Now, how does it do that? Well, light, even though it travels very fast, it still takes time to reach us because of the expanse of our universe. The further a galaxy or a star is, the longer it takes for light to reach us. With the JWST, we can see stuff from where light has taken literally billions of years to reach us. Another benefit of infrared observations is that infrared will allow the study of objects and regions of space which are obscured by gas and dust in space. Infrared radiation can pass more freely through regions of cosmic dust that would otherwise scatter visible light, so we would be able to see more galaxies and stars than normal optical telescopes. And since the images are much more sharper and detailed, we would be able to see a lot of things in the background of each images which otherwise would have been hidden from our view. So let us take a look at the first 5 pictures that the James Webb Telescope has taken. This picture is a galaxy cluster called the SMACS 0723 Deep Field. Each speck of light that you see in the picture are all complete galaxies which contains millions of stars and planets and perhaps even life. Who knows? The brightest stars in the foreground are stars which are in our own Milky Way, very much closer to us. This cluster of galaxies are 4.5 billion light years away, and what we are seeing are pictures of how it looked like around the same time our Earth was formed. The red streaks of light that you see in the picture are light from galaxies reaching us from 11 to 13 billion years ago, just a few billion years after the Big Bang. Remember that it takes light 100,000 years to go from one end of the Milky Way to the other. And here we can see light from billions of light years away. This is the farthest into our universe that we have ever seen, and all that detailing is from an area of the sky as big as a grain of sand. How cool is that? Thousands of galaxies in an area as big as a grain of sand. Next, JWST released some spectroscopy from an exoplanet when it passed in front of a distant star. This is called coronagraphy. What is really fascinating is that the spectroscopy shows the presence of water on the exoplanet. Water, as per our current understanding, is one of the main prerequisites for harboring life. Of course, finding water doesn't prove that there would be life, but it is a possibility. So could there be an alien life sitting 1,000 light years away on that exoplanet? The third image is that of the stunning Southern Nebula, a dying star 2,500 light years away. This was captured by 2 instruments on the telescope called NIRCam and MIRI, and it shows gas and dust ejected from the dying star. Next is a group of 5 galaxies called the Stephan Quintet. The actual image has 150 million pixels, and it is the biggest picture that the telescope has captured till date. And then take a look at this data which shows the composition of what is in those galaxies. Look at this spiral ring of hydrogen around a supermassive black hole. This is the first time we are seeing such detailing of our universe. And finally, the most stunning picture of them all, a picture of the Carina Nebula, a huge star-forming region within our own Milky Way. There are hundreds of stars in this picture that we didn't know existed before this picture was taken. These spectacular images really represent the dawn of a new scientific era. We will soon be able to see many more galaxies and stars which we couldn't so far. We can probably identify other habitable planets where we can move in when the technology allows us. It is like you have a ringside view of the entire universe from your own backyard. So what more can we expect from JWST in the future? Well, the first batch of images took just 5 days to capture, and NASA says the telescope could have enough fuel to last for 20 years. So this is just the beginning. We can expect more discoveries, more unknown galaxies, and more beautiful images of the very universe that we are part of. We are certainly lucky to see such stunning visuals which epitomizes the grandeur of this universe. Now let us see a contrast between what we have just achieved and what we achieved before science came along. Our ancestors plotted the sky and came up with non-existent patterns called constellations and made up some stories, and then some of them thought they could use these stories to swindle people. Remember that constellations don't actually exist. It is a pattern-seeking brain that connects the dots in the sky and comes up with patterns in the stars, just like we perceive seeing elephants and rabbits in the clouds. Then our ancestors came up with a super absurd notion that these gaseous or rocky giants have a role to play in our daily fortunes. Even today, millions of people falsely believe in this ridiculous fortune-telling business called astrology and believe that these objects that are light years away have an influence on us. Astrology creates stories in the sky, but it is science that shows the real picture. This is where the pictures taken by JWST become so much super important. If the next generation sees these pictures and realizes the true story of what these specks of light in the sky are, they would realize how ignorant their previous generations were for believing in the influence of these patterns. The first batch of pictures clearly shows us the power of this incredible instrument in terms of a next big step in our search for life in the universe. That means we can see things further back in time than ever before, be able to see even fainter and more distant objects, taking us back into the very origins of our universe. One thing you're not likely to see is a supernatural creator sitting on his chair and getting this universe started and running it. Nope, that is not going to happen. No, never. So I hope you liked this episode. And what was your reaction to those first images from the James Webb Space Telescope, and what are you most excited to see next? Please let me know in the comments below. If you are new here, please subscribe to the channel and go to the videos or playlist section to watch all of my older videos. Also, I am putting a link to the playlist of my old videos debunking astrology and the story of the sky, which will come up as soon as I say, until we meet again, this is me Anand saying bye-bye from Pale Blue Thoughts.